Today we are going to delete element from Min-Heap, and Min-Heap we always know that root is less and children are having more value than the root. And suppose there is given that we need to delete an element from the Min-Heap, but which element we need to delete, it doesn't given. Then what we need to do, we need to delete the element from right to right, right to right, rightmost child, right child, rightmost element, or we can say the rightmost term of the Min-Heap, and its right child, that is 150. We are going to delete, but this is maximum element and root is minimum, so we cannot shift it directly. So first what we need to do, we need to shift this element here. So whatever element is there, we need to shift with this. So we shift this element here to here, so it will be 150. Then it will go up, because where it will go, so it will go up. So 150 came here, then 80 will go there, then again 40 is there, so what it will do, then 40 will go up, 40 will go up, and 80 will remain here. Then again 40 is there, then 20 is also there. Then what will happen, then 20 will go here and 40 will remain here. So when 20 will go here, then what will happen, this element will get deleted, this element will get deleted, this 10th element will get deleted. So how we can do, or how we can make entry like this, let's see. So before that we will do it in the form of array. So we write all the element from here. So what are the element are here? Initially 10, we have 10, and we have 20 and 30. The child of 10 are 20 and 30. Then 20 child are 40 and 50. Then 30 child are 60 and 70. Then 40 child are 80 and 90. Then 50 child are 110, 100 and 110. Then 100 and 110. Then 60 child are 120, 130. 120, 130. And 70 childs are 140, 150. And it is given here we need to delete an element from the Min-Heap. So what we can do, we can delete the rightmost node, rightmost child, so that is 150. So first we do indexing here. So indexing 1 2 3 4 5 6 7 8 9 10 and 11 12 13 14 15. So from 15 we will go directly to 8th one, where we will go directly 8th one. And here if you wish we can also do indexing, and so from 15 directly we will go to 8, half, approximately half. Child will go directly to 8. And so what we will do, we are deleting one element, so 150 will shift at the place of 80. Then what will happen, then again it's root node, that will be 4th one, that will be 4th one. So what will happen, 150 remain here, but 80 need to be shift here, so 80 will come here, 80 will come here. Then again it's root, it's second one, 4th root is second one, root child, root or parent we can say. So 150 will go to 8th parent, then 80 will shift it to its parent, that is 4th position, that is 40. Then 40 will shift to its parent, that is 20, so 40 will come here, and its parent is 10, so it will shift here, it will shift here, so 20 will come here. So in that way one element is get deleted, that is 10th one. So now 10th one is deleted because we want to delete one element, and we cannot delete directly like root or something else. We need to do the modification. So this is the way how we can shift the element from there to here if it is not given that which element we want to delete. So now what is left on, we can see here 20, 40, then 30, then 80, then 50, then 60, then 70, then 150, then 90, then 100, then 110, then 120, then 130, then 140. That's it. So we do the indexing, then what will come? Let's see. 1 2 3 4 5 6 7 8 9 10 11 12 13 and 14. Total 14 elements are remaining. Initially we have 15, now one element get deleted, so total 14 elements are there. So this is the way how we can delete the elements from the min heap. So how we what is the tree? Let's see here. From here, instead of 10, what will remain? 20, and its childs are 40 and 30 now, so it will like 40 and 30. Now instead of 40, what will come? 80 will come. The 40th child is 80, so it will come like 80 and 50 and 60 and 70, 60 and 70. Now after 80, what will come? Here it is not 50, it is 150. It is 150. So it will come like this, 150, and what is this here? 90, and rest child will remain same as it is here. So after deletion, the tree will be like that. So this is the way to delete the element from the min heap when element is not given.